Welcome back. This is 1.1, Sets, Venn Diagrams, and Set Operations. So we have our objectives here. You can read those if you want. All right, we're going to go over some definitions. So a set is a collection of objects whose contents can be clearly determined. The object is a set are also called elements or members of the set. So we have word description, roster method, and set builder notation. So we're going to do an example of each of those. So representing using a description. So it says write a word description of the set. So looking at all of these, they are P are the first 5 presidents of the United States. So Washington, Adams, Jefferson, Madison, Monroe. And then representing a set using the roster method. So it says C is the set of US coins with a value less than $1. So the set is using the roster method. So C equals penny, nickel, dime, quarter, half dollar. So you'll list them in order with commas separating them. And then those parentheses are called braces, not brackets. Because so if it's a square like this, squared corners, those are brackets. And then you also have parentheses. Okay, but for our set builder notation, we'll be using our braces. All right, an empty set is also called a null set, and that means it contains no elements, and it will be represented either by the empty braces, like that, or a circle with a line through it. So we want to find which is the empty set. So we have 0 in braces, 0, x such that x is a number less than 4 greater than 10, and x such that x is a square with exactly 3 sides. So we're basically finding one that's not true or that is completely empty. So the first one is not empty. It has 0 in it. It contains the element 0. B is 0, so it's a number, so it can't be an empty set. The next one, so it says x is less than 4 greater than 10, so that's the set of 4 to 10. And then D would be our empty set because squares have 4 sides and not 3. So that's why it's the empty set. All right, next we have our Venn diagrams. So Venn diagrams are either the 2 circles together, you have 2 circles like side by side, or it's contained in a universal set, so that U is the universal set. So it can contain all of the elements of that set. All right. So looking at this first question, it says use a Venn diagram to determine each of the following sets. So we want the universal set. So we want everything that's included in that set. So it would be U equals, and then our brace. And then that 1, 2, 3, and 4 describes the different sections of our universal set. So in section 1, we have A, B, and C, and then D, E, and then F and G. All right, next we want what's in B. So it doesn't exclude anything, so it wants everything that's in that circle B. So that's going to be D and E. And then it says set of elements in A, but not B. So it would be that ABC. because D is shared with B. So the set is going to equal A, B, C. All right, then it says the set of elements in our universal set, but not in B. So everything that's not in B. So we'll have A, little b, little c, and then F and G. All right, and then it says the set of elements in both A and B. So everything in those two circles together. So A, B, C, D, and E will be in that set. All right, the next one, it says definition of a complement of a set. So the complement of set A is simplified by A complement. So it's A with that little tick mark above it, kind of in that exponent spot. Is the set of all elements in the universal set that are not in A. So kind of it's like an inverse, if you want to think of it that way. That it's the opposite or what we don't want from A. Or it could be B complement, C complement. It just depends on what letter it gives you. So you don't want to include what's in that. All right, so it says finding a set's complement. So for this first example, we want to find A complement. So A is 1, 3, 4, and 7. So we want everything that's not those numbers. So we're going to cross those off of our set and then write what's left over. So A complement is going to be the set 2, 5, 6, 8, and 9. And that's it. So you're just finding what's not in A. All right, the next one is our intersection. So the intersections of set A and B is we're in A, the upside down U symbol, or the intersection at B. So A and B. Is a set of elements common to both set A and B. So usually it's that one in the middle. So that highlighted portion that you see here in this example, that's going to be A and B. So that's where they share those sets. All right, so this first example, it says find each of the following intersections. So we want to see in this first set what is the same. So 7, 8, 9, 10, 11, and 6, 8, 10, and 12. So notice they share 8 and 10. So that new set would be 8, 10. All right, now we want to look at the numbers 1, 3, 4, 5, 7, 9, and 2, 4, 6, 8. So notice they don't have anything in the middle. They don't share anything together. So when that happens, it's going to be an empty set. So either your empty braces or the circle with a line through it. So your empty set. All right, next we want to find out if our numbers 1, 3, 5, 7, 9 and an empty set have anything in common. Well, there are no elements in that empty set. So there's nothing that they're going to have to share with each other. So it would also be an empty set. All right, the union of sets A and B is written as A and then the big U symbol B. Is a set of elements that are members of a set A or of set B or of both sets. So basically it's going to include everything of your set. So for example, if we were looking at this example from the last thing, it would include these numbers, and these numbers. So everything in that set that they have together or not together. All right, so looking at those, it decided it didn't like that. Oh, where did it go? It zoomed out all the way. There we go. All right, so find each of the following intersections. So, it keeps doing that. So we have 7, 8, 9, 10, 11, and 6, 8, 10, 12. So we want to list all of our numbers, and we want to list everything in both sets. So we don't have a 6 in both sets, but it's in one set, so we include it. So 6, 7, and then 8 is in both sets, so that's good. We'll include that one. And then 9, 10, 11, and 12. So all of the numbers of our sets, because it can be either or all of them together. All right, same for the next one. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. And usually you want to go in order and have them in order for your answers. All right, and then C. So we have the numbers and the intersection with an empty set. Well, the empty set doesn't have anything, so we're just going to include that first set. And that would be your answer. And that is it for our notes. If you have any questions, please let me know, but go ahead and work on your assignment.